To solve the given inequality, let's first of all set it equal to 0 and solve that equation. So we have 3x cubed minus 4x squared minus 12x. I'm going to add 16 to both sides, and I will now have my equations greater than 0. So now I have a cubic, and so we can try to factor this. Sometimes it will factor easily, or we can use what we've learned previous in this chapter about our rational root theorem, which is if this has any possible rational roots, they're going to be of the form p over q, where p is a factor of 16 and q is a factor of 3. So the possible factors of 16 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. And the factors of 3 are plus or minus 1, plus or minus 3. So the numbers that might possibly work are all of our p's divided by our q's. Plus or minus 1, plus or minus 1/3, plus or minus 2, plus or minus 2/3, plus or minus 4, plus or minus 4/3, plus or minus 8, plus or minus 8/3, plus or minus 16, and plus or minus 16/3. So that's a review from earlier in the chapter. Those are the possible rational roots. So we're going to synthetically divide 3, -4, -12, 16. And we're going to go down this list of possibilities until we find one that works. And I think that one that works is 2. So I'm going to bring down my 3. 2 times 3 is 6. 6 plus -4 is 2. 2 times 2 is 4. -12 plus 4 is -8. 2 times -8 is -16, which gives me 0. So that means that this polynomial will factor into x minus 2 times 3x squared plus 2x minus 8. And so to solve this, we need to go ahead and factor the 3x squared plus 2x minus 8. And I believe that factors into 3x minus 4 times x plus 2. And if I set that equal to 0, I get x equals 2, 3x equals 4, so x is 4/3, and x equals -2. So I'm going to take each one of these numbers, and I'm going to place these zeros on the number line, and I'm going to place them from smallest to largest, so -2, 4/3, and 2. And then I'm going to do what I did on the last example. We're going to find a number in each interval, plug it back into our inequality that we have set greater than 0 to see if it's positive or negative. So if we choose a number that's smaller than -2, say -3, plug that back into our equation. 3 times -3 cubed minus 4 times -3 squared minus 12 times -3 plus 16. We get -65, which is negative. If we choose a number between -2 and 4/3, an easy one to choose would be 0. We're going to get 16, which is positive. Choose a number in between 4/3 and 2, maybe 1.5. If I plug in 1.5 or 3/2, I get a -0.875, so I get a negative value. And then a number greater than 2, say 3, will give us 25, which is positive. So now we want to go back and look at what we're trying to find. We want to find the intervals where this polynomial is greater than 0. So we want to choose the positive intervals as our answer. So our answer is going to be the interval from -2 to 4/3, or the interval from 2 to infinity.